My name is Eloy. Here it is. See my chin? Eloy Rodriguez. That's called chin reading. I'm just kidding. So let's start. First and foremost, I want you to ask me any questions at any time. Just raise your electronic paw. All right, let's start. How about we go over a little bit of these absolute values, and then we have an equation that we solve. We'll be solving equations that have absolute values and inequalities. Inequalities. So let's start with a little review. I'm going to go over here with my little arrow, and I think you can see here it says absolute values. Here's a little thing, just a review. Minus 7 equals 7. ¿Sí entiendes todos? Good. Then we go here, and the absolute value of 7 is 7. So what this does, it kind of like takes away the negativity, you see. And if it's positive, well, the number remains positive, all right? So just keep in mind, if you have something like this, don't let it trick you. I've seen people get tricked where they have something like this, where they have, ooh, that's cool. Minus, ooh, that's fuzzy. Let's get a nice cleaner one in there. There, how's that? Oh, that's not much better. So let's call that absolute value, but then I have like a negative, let's say a 2. Well, I'm doing this with my mouse, right? So you would think, okay, it's true, that this absolute value is going to, turn that into 2. But don't forget this little negative that's hanging out right here, right? So the answer is minus 2. Don't let that fool you. They do a lot of them. But in general, you'll see that there's always 2 solutions, you see? Here's another one. One answer is x could be 5, right? Because the absolute value is 5. And another answer is this, see? Minus 5. So there are 2 answers. So that kind of helps us solve this idea of what we call absolute values. These things are the absolute values. Do you see that? All right. So then let's do a quick review here of the inequalities. This means if you're looking for reading it from left to right, right? It's greater than. This is greater than. This is greater than, or possibly equal to. Notice the word I said possible or possibly equal to, and here look, less than or possibly less than or equal. So just to remember, I did this burrito monster, as you can see here. Right here is the inequality. Oh, that looks like he has a mustache, doesn't it? Hello, my name is Mr. Mustache. No, anyway, and inequality. And I put the teeth in the big, because you always want to eat the side that has the biggest burrito. This is a tongue, by the way. And so this is, and over here on this side of the inequality, look at what I got here. I got this small burrito, teeny weeny, burrititito. It's a burrote. Burritototote. That's a burritito. Anyway, we'll go from there. So that's just to remind you that you want to be the big mouth on the big side, yeah, a little on the little side. And so let's go from there. So let's try a little combination here where we don't use the inequalities yet, but we have an equal side. Oh, excuse me, I yawned. Okay. So far the dogs. If I see dogs running in here, they're just rambunctious, so don't just ignore them. So this is recall. Oh, well, okay. So recall what? I recall that this had 2 solutions. You see, voila, voila, and voila. So I'm going to use the same idea to solve this. See, I'm going to drop my absolute values over here. See it? And I'm going to set it equal to positive 1, and then, like I did over here, I'm going to set this one equal to minus 1. You understand? Okay. Now over here, I got what I got. I got a 5. You see that? Add 5 and add 5 on both sides of an equation, leaving me the 2x over here, leaving me a 2x over here, and minus 1 times 4. You see that? And over here, 2x. So, and then I'm going to divide both sides by 2, and it turns out that I have 2 solutions. X equals 3 and x equals 2, right? So then I say this means this is a 3-dimensional check mark. It looked more better if that was like connected over to here. Let's see if I put it like this. And I forgot this part. There, look. There, now I feel better, don't you? It looks like it. Later on, if you'd like, I can show you how to do some of these 3D sketching things, which I kind of like. I like to do geometric shapes on a program called SketchUp. I'll show you. Okay, now let's check the work. So remember, x equals 3, so I'm going to plug it into here, see? So now I have 2 times 3 minus 5. Well, that equals 1. That's good. Check. And then how about over here? Oh, let's try 2. So let's put 2. I'll put 2. I put 2 in here. See it? Bing. So 2 times 2, huh? Yes. Excellent. Excellent mundo. So now let's graph these solutions. Now, because there are only 2 solutions, what are they? This one and this one. Well, when I graph them on a number line, guess what? It's just dots, solid dots, because there are only 2 and no other values of x will work as a solution to that equation. Got it? It is kind of poetic, isn't it? It's pretty. I think it's kind of pretty. So let's try it over here. What do I got? I have an absolute value of now. Guess what? We introduced, yes, the inequality, an inequality, or we can say inequality. Now, so recall. Here's a recall. Look how these guys operate. True. Look, I just dropped the parentheses. I mean, I dropped the absolute values, and look what happened. Ooh, and look at that. That stayed the same direction. See it? Here it is. But when I multiply it by -1, if you can think of it that way, and then I can flip this flips. See? So guess what? I get 2 solutions. I have all values of x. That this looks like I better get rid of that piece right here because that's too big. Okay, never mind. So I'll go over here. Look, I want all values of x, right, less than or equal to 1. So let's use this guy here. Look, I'll go here. Right? Notice that I'm using this curved little parentheses looking guy. It means that you can come right up to the right, close to 1, but you can't actually use 1. That's why it's rounded. If I wanted to actually have it, I could have, like include it. I would probably use a square parentheses like that, meaning that that's going to include that. Or you can simply put like this red point right there, red solid point, and then out. This is supposed to be an arrow. You see it? So all values of x, that's this guy, that are less than 1. And what about over here? Oh, all values of x that are greater than -1. Well, I did that in red, actually. See it? Look how that mixes colors. That would be this guy. And notice it's a rounded thing again, right? It's rounded. Meaning, it's rounded. Like a parentheses, like a nice parentheses. So it means all values of x minus a half, minus 0.999, 0.99999, all of those are really good, except you can't actually use -1, but you can use everything else. And guess how far this goes with? That goes to the infinity, positive infinity. And if we were going the other way, like this guy, we would be heading off to, that's probably better in green, huh? We'll be up, there you go. This is like a lazy 8, right? 8 on its side. That reminds me of a math joke I'll tell you someday. So here we go. Now, let's see. Look at here. So here's another, this is a special kind of parentheses that tells you a set of collection of possible solutions. Look how to read it. Go to the middle. I want x's. What kind of x's? I want all x's that are anywhere. Between what? Between 1 and -1. Got it? Good. That's great. That's working good. Okay. Now, so here again, I want all values of x, right? This is all values. This means that all values of x greater than 1, but not actually including -1. And right here we have, this means what? All values of x, see, it's rounded less than, but doesn't actually include 1, but every value all the way out to this negative infinity guy. Okay, it's kind of fuzzy. I think because I zoomed it up. If I zoomed it down a little, it'd probably help a little bit. Zoom out. Did I zoom out? Yeah. I zoomed out. That's okay. There we go. So now let's move back up and go down here. So let's go back down. All right. And so now we have this example here where look what we did. Let's go over here. Let's try this again. Oh, look what happened. And I wrote this without the absolute value, and here I got this as greater than 1, and here I wrote it without the absolute value, but this is less than -1. Remember? That's a lot like what we did over here. See? The x is less than 1. So I had x is less than 1, and x is greater than -1. This flips. So just write it like that. So I wrote it again like that, except instead of just having absolute value x, then here I'm talking about the absolute value of 2x minus 2 squared root of 1. So what are we going to do? Oh, well, we're going to solve it just like an equal sign. Yeah. The only thing that you need to be careful is that if you ever multiply both sides by a negative, these inequalities will flip directions. Because a negative is a positive, so a positive is going to be bigger than a negative was before. If that makes sense. I'll show you what I mean. In other words, if it's true that you know that negative 5, right, is going to be less than, let's say, let's say 4, right? Or if you want to read it Chinese, like from right to left, you could say, oh, 4 is greater than minus 5. However, if I decide to, okay, I'm going to take this and multiply by minus 1 here, I'll put that in parentheses, and let me put this in parentheses so you know I'm multiplying it. And then over here too, okay? And I got this as minus 1. Ooh, just barely fit. So now I got minus, minus and a minus is going to be a positive 5. You see it? And over here, we got negative 4. We cannot say that 5 is less than 4, so this guy has to flip. See, that's what I'm talking about. Otherwise, it wouldn't make sense, would it? Okay, so let me get rid of that. See if I can get rid of this. Oh, there's my eraser. Look how big it is. That's a noise it makes. Okay, so what do we got here? Let me go back to my arrow. Look, so now we're getting ready to solve it. What did I do? I dropped my absolute value here, and I dropped my absolute value here. See it? That's gone. And this guy has changed directions. And then I put this negative 1 guy here. See it? And this guy, it's in the same direction. So that's all you do with these. So now we pretend like it's an equal sign and just work through it algebraically. And so now we have, add 5 to both sides, yeah? 1 plus 5 is 6, and then in order to get that x by itself, I divide both sides by 2, and what does this limit? Bring down the inequality. I want all values of x that are greater than 3. Is that good? All right, that's really good. And then also on this side, I have to do that too. Add 5, and there it is. And there you have it. Look at that. Now, let's take a look at this graph now. I want all values of x that are less than 2. Well, anything this way is less than 2, right? And then on this one, I want all values of x that are greater than 3. See? Now notice that this is a gap here. We call that a disjoint set, right? Because there's a gap. Over here, by the way, there is an overlap. You see? There was an overlap with red and green. Where that overlaps, that's going to be my new solution set. That overlap is from minus 1. Any value of x from minus 1 to 1 is a good answer. It is a good answer. It's just that it can't actually have minus 1 in the set and 1 in the set. If it did, I would put equal sign under here so it could be less than or equal. Okay? And then I would have changed these guys to more rectangular bracket looking thing instead of these rounded looking things, right? Or you could put the open circle, meaning it doesn't actually think, or a solid circle like this. The solid circle up here, see it? That means that actually that point and only that point. Whereas you can write this with the open circle if you wanted to. That means it's all the way up to that point, but not actually that point. I like the parentheses stuff. Okay, so then we have two things. One where the set is overlapping, like this, and one where it's disjointed. You see that? Okay, that's good. Let's try that next. Okay, so now this is what we're all about. Look what we got here. An absolute value, right, minus 3x. And then we're going to have, ignore this for now, this is a disjoint set. So now, let's see how we can rewrite it. I'm not sure when I got this thing. I don't know. Okay. What I did is I just got it so I have the absolute value by itself on the same side, you see? So I added 3x to both sides, same problem. But remember now, we can write this two ways. How? With this inequality going this way, see it? Let me go this way. Notice how it stayed the same. This position here is the same direction as this one, right? But now when I drop my absolute values here, look what happened. When I put a negative of all this stuff here. Notice I put a negative in front of it, and now I have got rid of my absolute values, and I have this going in the other direction. See, change directions, just like it did with other arguable examples. So we solve through it, solve through it, solve through it, and look what I got. I have x is greater than minus 4. Okay, how about minus 4 is greater than x? Or, you want to read it from the left? I want all values of x that are less than minus 4. Yeah, and let's go to this one. Oh, so what did I do? Like here, okay, I subtracted 2x from both sides. And then over here, I started to combine my x's. So what I'm going to do is add 3x to both sides, right? Well, be careful, because when I bring the negative in here, right, it goes here, and like looks like a little horn. And then I go over here, you see it? Yep. And so that's why this changed to minus 1 and minus 3x. So that's why I added 3x to both sides. Yeah. And then what I did at this point, I said, oh, well, look at that, 2x plus 3x is 5x. I got minus 3. So then I add 3 to this side, and now I have 5x, right? And then I divide both sides by 5, do you see? And if you take, what is a fraction? A fraction simply means that you take the top guy, you put him in the box, the division box, you see it? And you divide it by the bottom guy. The top guy is called the numerator, and the bottom is called denominator. And since we know that's too big, the rule is you bring a decimal, bring it up here, see it? And then throw in a 0, and by the way, that'd be like 40%, or 4.4. So I want all x values that are less than 0.4. And then I want all x values, you could read it either way. This says minus 4 all value, but this is better. Start with the x. I want all values of x that are less than minus 4. Less than minus 4 means more negative. So let's do that. We'll be done. Okay, here we go. I'm going to do that in black. So let's do this number line. Of all possible, I put a capital X here because it means all values of x in here. That's not too straight, is it? So here's 0. So I'm going to go 1. And then, that's 1. And then I'm going to go minus 1. Right? And this is going to keep going until I get to the lazy 8 on the side. See it? And then over here I got positive 8. Okay? That goes to positive infinity that way. So this would be halfway. It'd be like 0.5, right? So just estimating, we're going to say that this part right here is 0.4. Now, am I going to use what kind of parentheses? A square parentheses? A round parentheses? This is minus 4 going right here. It doesn't, not minus 4. This is 0.4. So now watch. I want all values of x. What did we say? I want all values of x less than 0.4. That means I don't actually want 0.4, so I put that guy, and I go all the way out to negative infinity. That's okay. How about the other guy, this guy? Start with, I want all values of x that are less than. Oh, well, that's easy. It looks to me like we have an overlap here, don't we? So here now I go to minus 4, which I didn't even put in. There's 1, 2, 1, 2, 3, 4. Yeah? I wonder if I can move that. That's pretty cool, huh? Can I move that? Oh no, that's for text. Oh. No, I don't want that. Get rid of that. Huh? Delete that thing. I wonder if there was a way that you could kind of move stuff around. Anyway, I just get rid of it. So I go here. Yeah. There's that noise again. I don't know how it does that. It knows exactly when I'm going to move my lips. Here we go. I'm going to get this guy here back on. And I'll stretch it out here. Okay, and I'm going to call this minus 4. Well, that's already been taken with this guy, hasn't it? Notice that this guy's going to go forever this way. It keeps going. This is the arrow, right? And there's my minus lazy 8. This is kind of hard to do with a mouse. Okay, so now what does that look like? Well, that's also all values more negative, less than, that way. So it's already, when you got this one, it covers everything, including that one. So your solution for all these are any values of x here, because, oops, that doesn't look so nice. Yeah, like this, see? And there you go. Okay, is that cool or what? Is it just me? I don't think so. I think it's cool. So why didn't I put this other guy in here as part of the solution set? Because it's covered. all values from here to the left also cover all values from -4 to the left. Do you understand? That's good. You guys did well. You can, well, what I'd like you to do is go through this again, my notes again, write them all out, hand it in to me. Okay, and we'll go from there. By the way, this is supposed to be like just a separation between one thought and another. And I think that's about it. Oh, I was going to show you very quickly. I don't know if I can do it here. I'll see if I can share this thing right here, which is what I've done. Yeah, what do you think? Look at this. I did these sketches on SketchUp. Actually, it's a 3D. Watch what happens when I turn it. Voila! Look at that. Is that something cool? Anyway, I can show you how to use it. This software is for free, by the way, SketchUp. Okay, well, I enjoyed our time together. Write me an email or something. Let me know. Adios.